So we're going to talk about 3.5 today, Foundations of Math 30. This is we're going to talk about conditional statements and their converse. Okay, so a conditional statement. If we talk about conditions. If you say there are conditions involved with something that I'm going to do, what that means is you're really saying if something happens, then I will do this, right? And an example would be for a conditional statement. Something like, if it is Monday, then it is a school day. So this is a kind of a statement that we can make. And what makes it a conditional statement is that something sort of has to be, has to happen first. If this happens, then this will happen. Or if this is true, then this is what should happen. So we make a statement, and it's called a conditional statement if we have really if and then in the statement somehow. Right? So if it is Monday, then it is a school day. If it is flannel day, then I will wear flannel. Okay? Now, we're going to explore the truth of these kind of statements. We're going to examine it a little closer, and that's part of the reason for our day today. But there's two important parts of a conditional statement, and one is the hypothesis. Okay? And the hypothesis is what immediately follows the if. So if you look here, our example that we're using, if it is Monday, then it's a school day. Well, the hypothesis is the it is Monday part. Okay? So, like in a science lab, you make a hypothesis. You kind of guess about what's going to happen in your lab, right? That's a section that's right up near the top, and before you even do the lab, that's what you're supposed to sort of, think about and try and make a hypothesis or an educated guess about what's going to happen. So it comes at the beginning, right? And in the conditional statement, it follows the if. The conclusion is what the other part is called, and it follows the then word. So if it is Monday, then what comes next? It is a school day. So the conclusion follows the then word. Okay? And there are many statements that you can make, right? If you're in this class, then you're in grade 12. Now, that's not always true, right? Because there could be a grade 11 student in this class. So that's a conditional statement, but whether it's true or not requires us to go a little bit deeper. So that's what we're going to examine here. Okay? So we're going to take a look at this example right here, and we're going to evaluate sort of, when this statement is true and when it's false. So we're going to dig into it just a little bit. So here's the example from your textbook. If you want to read along your textbook, I have this is exactly from your textbook. But this is the example. The conditional statement says this. All right? If it is raining outside, there's your hypothesis, right? Okay, it is raining outside. Then we practice indoors. So here's a coach, for a soccer team or whatever, and he's making this statement. The hypothesis is it is raining outside. Now that could be true or false, right? The conclusion is we practice indoors. That could happen or that could not happen. So what we're going to be examining is the truth of the statement based on what is actually happening. So is it raining outside? Okay? Or is it not raining outside? And so on. We're going to try the different cases. And to evaluate the truth of a conditional statement, we're going to consider 4 cases here. Okay? So let's move through them a little bit at a time. And this will help you kind of understand how we evaluate these. So case number 1, the hypothesis is true. So that is, it is raining outside, or it rains outside. And the conclusion is true. We practice indoors. So if the hypothesis is true and the conclusion is true, then what do you think that would mean? Would that mean a true statement? Is that a true conditional statement? Yes. The coach has kept his promise, and the coach's conditional statement is true. Okay? So you kind of evaluate sort of what's happening. So if the hypothesis is true and the conclusion is true, then that's a true statement. That makes sense, right? Okay, case number 2. What if the hypothesis is false and the conclusion is also false? And what that would mean in this case would mean it doesn't rain outside, and we practice outdoors. Okay? Now you have to think about, is that consistent? Is that consistent with the initial statement? So is it a true or false statement? And here's the reasoning. If you consider this, since it doesn't rain outside, the coach is not obligated to keep his promise. We can practice either indoors or outdoors. So the coach's conditional statement is still true. Okay, so if you think about that, it's not raining outside, we're going to practice outdoors. Okay, his statement, his original statement, is still true. It's verified to be true. Okay, because what he said was if it's raining outside, we practice indoors. Okay, so if it's not raining, we can practice outdoors, and there's no conflict with this statement. It's a true statement. Okay, are you following me? This is a bit of logic, and I know it's kind of heavy, but that's why we're going to go through it piece at a time here. But we're evaluating the truth of statement. Just like I said, if you're in this class, you're in grade 12. Okay, well, let's, we could examine that hypothesis. Okay, so what about if you're not in this class? Okay, could you also not be in grade 12? Does that make sense? Yes, there are lots of students that aren't in grade 12 that are not in this class, right? That makes sense? Okay, so that's kind of how we're tackling it. All right, so let's go back to this example. What happens if the hypothesis is false? Okay, so it doesn't rain outside. It's the opposite of what originally is said. And the conclusion is true. So we've got false and true. So it would look like this. It's not raining outside, but we're going to practice indoors anyways. Is that okay? Is that original statement still a valid, true statement? So it's nice outside, but we're going to practice indoors anyways. Has the coach broke his promise? Well, no. He's not obligated to keep his promise because this hypothesis here is false. So we can practice outdoors or indoors. Okay. So this is okay. So we still have the conditional statement overall is still true. So here's the case where the conditional statement would not be true, right? If it rains outside, so this is the hypothesis is true, but the conclusion is false, and that makes sense, right? If this happens, then I'm not going to do what I said I would do. Then the statement is a false statement, right? The coach is a liar, sort of thing. So when the hypothesis is true, that means it's raining outside, but the conclusion is false. We practice outdoors. That's a clear violation of the original statement, right? So the original statement is false then. All right? So the coach has broken his promise. We should be practicing indoors, not practicing outdoors. Okay? So if this happened, and it actually did rain outside, and the coach said, you know what, we're going to practice outside anyways, that would be an example that would make that statement false. So we're going to talk about something called a counterexample, and you guys probably know a little bit about a counterexample, right? It's like the exception to the rule. So if you have a rule, but you can think of one exception, that rule is not really valid to everything, right? It's not a complete true rule. So a counterexample, okay, right here, it's an example that disproves a statement. An example that disproves a statement. So if you think about our soccer example, someone says, hey, it was raining outside and the coach made us practice in the rain. Okay, well, that's a counterexample, meaning that his statement is not true all the time. Or if we go to our example, or my example that I mentioned earlier, if you're in this class right now, you're in grade 12, well, if we had one grade 11 student in here, then that statement's not true, right? Okay? So then there's lots of conditional statements you could probably think of right now, where if you thought of one counterexample, you know that statement is not a true statement all the time. Okay? All right, so how can we make a little bit of sense of this? I'm going to show you something called a truth table. All right, again, this is in your textbook as well, and whether you write this down in your notes doesn't really matter to me. I'm going to go through it slowly enough that you can write this down and ingest this, and I would certainly recommend that you jot this down in your notes so that you can actually, focus on it. But if you want to just watch up here, that's fine as well. So this truth table sort of summarizes the four cases, okay? And if you want to evaluate the truth of a conditional statement, if you think about this table, This is sort of a summary of all that we just went through. So P. Now, did we talk about P and Q? Okay, maybe this is the first time we've seen P and Q. Okay, obviously P is the hypothesis. Okay, so that's something you want to make sure you know. P is the hypothesis. Q is the conclusion. All right, and this notation here with the double arrow, this says P implies Q. Okay, so if it's raining outside, that would imply that we practice indoors. That's the nature of the statement. Okay, so that's P implies Q. Okay, so a little summary of what we did. Case 1, both are true, right? It's raining outside, so we practice indoors. The statement is true. If it's not raining outside, we practice outdoors. That is okay too. That is consistent with the original statement. The original statement is still valid. If it's not raining outside, but we practice indoors anyways, that is okay. That is consistent with the original statement. The only one that's false, and this is really all you have to remember when evaluating a statement, this is all you have to remember. If the hypothesis is true, but the conclusion is false, that's when the statement is false. Okay? So if you examine your truth table, really you can just put, okay, is this, think about the hypothesis, is it true? Yes. Is this true? Yes. Okay, so I'm true. The only way that the conditional statement would be false is when the hypothesis is true and the conclusion is false. Otherwise, the conditional statement is true all the time. So this is important for you to remember. It's false only when the hypothesis is true and the conclusion is false. Okay, so the next thing I want to talk about is something called biconditional. Okay, bi means two, so you can think about it this way. It kind of goes both ways, goes two ways. So if P, then Q, but also if Q, then P. If both of those statements are true, then we have something special called a biconditional statement. So what is a biconditional statement? It's a statement whose converse is also true. Okay? Now, converse, okay? So we need to talk about a converse as well. I said that biconditional means it goes both ways. So let's talk about the converse of a statement. Okay, so a converse is a conditional statement in which the hypothesis and the conclusion are switched. Okay? You may have heard, some people saying, well, this and such and such and such, but conversely, this is also true. So, they're saying this, but also if you consider it the other way, right, conversely, okay, the converse, it means that the hypothesis and the conclusion are switched. That's literally what the converse means. So when we talk about a biconditional statement, it means that the original conditional statement and the converse, they're both true. Bi means two. Sorry. Okay, so bi means two. So the hypothesis and the conclusion are switched. That's the converse. And a biconditional statement is when both are true. So here's a math example down here. So we may as well just go through this one. And what we'll do is we'll think of some biconditional statements as well. So, okay, so the example here, if a number is even, then it's divisible by 2. Well, being divisible by 2 is the definition of an even number, being evenly divisible by 2. So that is true. The converse would be when you switch things around. So you'd say if a number is divisible by 2, then, what's the hypothesis? The number is even. So if a number is divisible by 2, then it's even. That is also true all the time. So this is a biconditional statement. So let me throw one out there for you, just as an example. I'm going to say that if it's a Saturday, then it's not a school day. So is that biconditional? What you want to do is you want to flip that around and see if that converse is true. So I said, if it's Saturday, it's not a school day. So you think, if it's not a school day, then it must be Saturday. Or then it's Saturday. Is that statement true all the time? No, it's not, right? You think about Easter holidays, Christmas holidays, summer holidays. There are lots of Tuesdays and Wednesdays and Fridays that it's not a school day, right? So that's not biconditional. The converse is not also true, okay? So can anyone think of one now? Anyone have an idea? Even if you're not sure, why don't you just shout it out and then we'll examine it. No murmuring? If today is Monday, then tomorrow is Tuesday. Let's flip that one around. If tomorrow is Tuesday, then today is Monday. Can you think of a counterexample for that? And then again, all you have to do is think of one case where that's not true, and then you can say it's not biconditional. While in reality, if tomorrow is Tuesday, then that must mean that today is Monday. So that converse is also true. So both, both statements are true. So that would be a biconditional statement. Okay. How do we write biconditional statements? What's the notation? Here's the notation. We have P, so that's P is our hypothesis, and then we have a double arrow. Those of you that were in chemistry with me, you know what a double arrow means, right? You've seen that before. In chemistry, what does a double arrow mean? What is that talking about, chemistry people? Reversible reaction. Very good. Yes, a double arrow. So if P then Q is true, but also if Q then P. See, it goes back and forth. Beautiful. So the statement can be made like this. This is what you can actually say, and this is how they say biconditional statements. P if and only if Q. Okay? It means that both the conditional statement and the converse are true. So P if and only if Q. It is Tuesday if and only if today is Monday. Tomorrow is Tuesday if and only if today is Monday. Okay, if that makes sense, that's how you summarize a biconditional statement. Alright, the last thing I want to talk to you about here, just going to go over this real briefly. We've been talking a lot about Venn diagrams, and there is a piece in here about Venn diagrams. If you think about a conditional statement, okay, what you want to do as far as the Venn diagram goes, the hypothesis, if that's a subset of options there, okay, or an option, the conclusion would be another set here where P is completely inside of Q. So you can represent a conditional statement using a Venn diagram. The inner oval or the inner circle represents the hypothesis, and the outer represents the conclusion. The statement P implies Q means that P is a subset of Q. So that's important. So in this P implies Q conditional statement, P is a subset of Q. So in order for it to be true, right, if it rains outside, that means we're going to practice inside. And here this Q would be practicing inside. So if this P happens, it's raining outside, then we're automatically in the outer circle as well, right? If you think about that example, if it's not raining outside, okay, here's raining outside, here's not raining outside, everything outside of that, we could practice indoors, or we could practice outdoors, right? But if it's raining outside, then we must also be in the conclusion for a true statement. And just keep in mind here, as I was talking about counterexamples, only one counterexample is needed to show a conditional statement is false. So if you can think of one counterexample, then your statement is false. All right. There are many more examples in the textbook, and I don't have time to go through them all. So when you're doing your assignments, if you run into something that is saying, hey, this is a bit of a different question, then remember what you do. You go back into the textbook, and you look through the examples, and you try and find one that's similar. Okay? Because every question in the assignment is either directly or indirectly related to the examples in the textbook, or the examples that I've given in class, and or something that I've talked about. So there are ways for you to find out how to do these questions from the textbook. That's the way it's made. The questions in the textbook and the material in the textbook are always related, either directly or indirectly. So again, I don't have time to go through, all 6 examples here, but I'm going to give you your assignment so you can get started.